All right. All right. If you'd allow me, I'd like to introduce tonight's speaker. His name is Tom Huckabee. He's a Lean Six Sigma black belt and an Agile specialist. He has a master's in technology management with an NSA certificate. In his career, he has served as an information systems program manager, special projects architect, and adjunct graduate school professor, both regionally and nationally. He teaches and develops courseware and systems for information and knowledge management graduate programs. He currently works for SR&S Operational Technology as the Chief Agile Architect. Please join me in welcoming Tom Huckabee. Tom?
I feel like clapping, but I don't
You're
think
muted,
I'm gonna
Tom.
clap.
Yeah, we never said that we were masters of technology, but I'm really excited to be here and to share. I'm going to start sharing screen. I don't think it's being shared right now. Is that correct?
Looks like it is. Looks like it's being shared. Go to the next slide and we'll know.
Okay. All right. So I'm seeing the Central Savannah River.
Yep.
I'm going to the next slide, and we should be a sketchy light bulb.
Yep, we are running.
We call it digital transformation. I'm particularly excited about doing this. I'm always excited about sharing from Agile. It was a breakthrough set of ideas that I had been looking for most of my professional career. And about 15 years ago, I had done some initial Lean Six Sigma work. Worked with some people doing some of the processes that we had. And then, so that's what got me started in this. And it was primarily what I particularly liked about it that attracted me was because I've come from systems development and design. And it was the statistical modeling. So I am a bit of a geek. And to be able to mathematically test a system before you build it, that's what you can do in the wonderful world of Six Sigma. Okay. But what I learned along the way was that in the lean world, it gave you all the things that you want to do with the people side of the equation. Okay, it focused on the people, and you'll see that in the presentation in a minute. Well, what's come along lately, and particularly relevant to this topic that we're going to do, is the Agile digital transformation. That's what the DX is. If you've seen any of the stuff out there, you're going to see OTDX or organizational DX, and that's the little abbreviation, but digital transformation. Well, I'm going to give you the value proposition up front and see if I can prove to you the value proposition from some data that I have access to that over the last year that I've pulled together. And so we're going to look at digital transformation of the operational technology, OT, along with Agile team approaches. And of course, we're differentiating here a bit from what people are used to thinking about is IT, right? Information technology. This is the operational technology side of our enterprises and organizations. That's where I work. Okay. And so what's new here? Okay. And why should you folks in the Association for the Advancement of Cost Engineering, why should you care? Well, your purpose, because I looked this up and I'm looking at it right here now, is that you're in the business of trying to find better ways and more effective ways to manage cost engineering as across project management and the related disciplines. And I'm here to tell you that Agile Digital Transformation offers a modern approach to project delivery that can have significant benefits for cost efficiency, risk management, and value realization. And it's the more complex the project, the higher the payoff. Okay. All right, so let's look at the components of it and see if we can define our terms a little bit. What is the OT digital transformation? We're going to dig into that a little bit. So I'm going to throw these questions out to kind of guide our presentation here. What is Agile? I get asked that about half a dozen times a day, it seems like. And what happens in a happy marriage? That is to say, AgileDX. Okay. First, we'll start with the obvious components of the digital transformation and see if we can kind of put something around that. There is a sort of an evolutionary term out there that you'll see is called let's see, industry 4.0, okay, or manufacturing 4.0, okay, and it really ties things to what we go back and thinking of the industrial revolution, that kind of thing. And industry 4.0 is getting into all of the updated technology and methodologies that can impact the operational technology environment these days. And so what does that consist of? Okay, we've got these, what we've had for a long time is digital process control. Well, there's a natural evolution that occurs over time, and it's been moving forward quite well in the last couple of decades, and that we are now in digital process control thinking of terms that we call human-machine interface and user experience. It used to be we just thought of the switches and the gauge readings, but now we're trying to make sure that we're thinking about how to make operators more efficient and effective. So what's come on the scene, just in a natural evolution of processes, is in this digital process control, the more thinking about how can we help the performance of operators to not make mistakes and those kinds of things. The next technology that's come along is in sensor technology. These days, what we have that's really come on the scene in a big way is, rather than having to have just worrying about getting control and feedback and switches, we now have such things as the visual recognition that we can play into. We have ultrasound type. If you really think of our five senses, all of the five senses that we have as a human being, and that's what I use this word mimicry for, can now be pretty well applied to the sensor technology these days. We can use ultrasound and vibration analysis. We can pick that up and start working with that. We can use thermography, where we're sensing the technology from that way. And seeing what's happening as things heat up, whether it's electrical or friction within our systems. And then, of course, we have, that's moved very effectively. We now have what we've been trying to get to, and we really couldn't move forward very, very far in the digital process if we didn't have real-time feedback, and that the speed of our transmission and the feedback now is almost instantaneously, particularly with the networking capability we have now and with the wireless technology. But all of a sudden, within the last decade, especially in the last handful of years, there's a whole new set of technologies that have come in or come into their own that now can be applied to improve what was already good technology and good engineering that have been steadily improving in the digital process control and the sensor technology, and then the processing speed in communication technology. Okay, so what came on the scene was the realization, this Internet of Things, right, that you have all around you in your personal world. Well, it wasn't very hard to take the leap now to say, hey, because especially of the wireless technology and wireless mesh and transmission, that we could very quickly and easily start connecting things that we hadn't even thought about before in our personal lives. Well, guess what? We can do that in our technology or operational technology world. Okay, I'm stuttering a little bit here, but we'll get that worked out. Okay. And then the next thing to come along was, with all of this data, it used to be, I mean, I've worked in places we have 70 years worth of data that we can't even get to and use. Well, look what's come along in the last couple of years, this what we call big data. Well, we always had the big data if you just thought of how much it was, but now what we have is the ability to process that data in meaningful ways and to pull out the information. This is the whole new data science world. If you don't have a data scientist in your organization now, if you've got a big complex environment and work going on, you really are missing opportunities to start turning that data that's been laid out there for all these years and be able to do something with it and start teasing out real information and real knowledge from all of that data that you can put to use. And that is really a rapidly emerging science. And then, of course, because of the processing speeds and the cloud services these days, what we've really moved into now is that everybody and anybody can get supercomputing in their environment. Okay. And so with that comes the ability to take all that data and all that technology and start moving aggressively into representing things very accurately and very with high refinement and to be able to modeling things no matter what phase of a project you might be in. Up front, when you start designing, I can take all that data and all that analysis that goes with it that I can now process, and it will influence and help build out more useful designs. And then as I'm designing with that modeling capability now, I can start seeing things that I would never be able to see until I actually went into the physical world. And it's amazing the number of times that we have in our designs as they start putting into good models, we will recognize interferences that we would not have seen until we started to build something. And those kinds of benefits are starting to emerge. Okay, so in the defining world, we're able to do better project and initiative definition. Then we move into the designing world that we can take those starter models that we had and increase the fidelity on those and the detail and the work and start doing things with those in the conceptual design world. But then even as we've worked through the conceptual design, now we can have people look at them and work them and give us better feedback. That's getting close to, and even with virtual technology, we can have people go into these environments and work around. Now we move on to the area of once we've perfected that design and those models, we actually can move into the operational side of things. And those same models now, which are, quote, digital twins of the real world, we can use them for controlling the systems. That's not all. Now that we have those models and now that we're controlling and we discover some possibilities for improvement, we can model those improvements alongside of the real world with our virtual world, and we can do the testing that I referred to earlier, that we could actually do virtual testing to see if we could, if this idea that we have for improvement will really work. So this is what the digital transformation is about, okay? So I gave you kind of the natural evolution in the digital process control world, but then with the new technology coming into its own and along with the special capabilities that we have now, even including the artificial intelligence, by the way, which is a kind of a blend of the big data and then the high fidelity modeling kind of world, then all of that coming together is what we now have as the opportunity, okay? As a matter of fact, the opportunity is so big and so complex, it really does take specialists in doing this digital transformation. All right, so let's talk about the people side of the equation. And that's really the most favorite part that I have in this, and that is, what are the essentials of agile engineering teams, okay? So we looked at the essentials of the operational technology, then what's come on the scene and what the possibilities are. But really, there are experts out there that say if you don't have an agile mindset and have a growing maturity in agile engineering methodologies, then you really will not be able to pull it off, because there's such a complex set of interdependencies that are going on, and the changes that you have to make to your organization, your enterprise, that you really do need to get schooled in these agile methodologies. So let's look at what they are. Okay. The first one is this consummate focus on customer value. Okay. So it's not about delivering something or technology or even the machines, and those are impressive as they can be, and they're fun to look at and work with. But really, at the end of the day, it's still about delivering customer value. And so every move that our teams ought to be thinking about as they engage the technology is, how will this improve the customer value? So I hope that makes sense. All right. Then you're going to find all these agile engineering thinking ideas are really about people. Okay. So we're going to manage the value stream visually. We talked about the great benefit of the new technology is that we can see things that we couldn't see before. It used to be that you had to go down, even as you looked at the dials and instruments that you were working with in the distributed process control that moved into digital process control. Okay. Many times you still had to go down to the front line to look at the things to really understand where things were and what the progress were and statuses and so forth. Now we have the ability to do what we said we really needed to do, was to visually have everybody be able to see the status of the value stream. And notice we're not talking about, quote, the process. We really are, but we're giving it a new name, because since we're looking for customer value, we want every step to be incrementally adding value. So that's a value stream to the final product delivery. Okay. So these are concepts and mindsets that we're talking about. The next thing is that as we're engaging as a team to get things done, we're looking for anything that will stop the work of flow. You may have heard of the theory of constraints and barriers and impediments and all those kind of things. Well, those things are out there, and they just grow in every process like barnacles. Okay. So what the team starts recognizing, an agile engineering team, are the impediments to flow. Okay. Because anything that's killing flow is stealing value from the value stream. Okay. So there's a concept that we really need to drive into people. The next thing is that we need to produce on demand. Okay. So you've heard the terms just in time or producing on demand. Really, the proper term here is producing at the downstream demand. That's called pull production. And it's a little bit of a harder concept to get, but once people get it, that means I'm not going to produce ahead of what the process can deliver. If I do, what happens is you start building up. We call that overproduction. You start building up inventory in different places. So anything that impedes the flow is we're looking for, but also we want to be producing on demand. And the theory of constraints says that your process is only good as your most constraining step in that process. So there's a whole set of techniques and science that we use to identify those things and start pulling those out. So that's kind of like your chain is only as strong as your weakest link, right? So we want to produce on demand, keep the flow, and if we have any constraints, we need to be looking for that and getting rid of that. There's a whole science to that we can address. Right now, we're just screaming across the top. But here's the next one, that everything can be improved, and we need to individually and as a team develop a continuous improvement mindset. Okay. And I love one of the significant thought leaders in this space. He calls it, he wrote a book on it. It's called 2-Second Lean. And he says, if you can't think of anything, figure out how you can improve the process by 2 seconds. Everybody can figure out a way to make it improve by 2 seconds. Well, then he does the math to show you how quickly that 2 second multiplied across all the teams and all the processes that you have adds up pretty fast. And as you think about that every day that you engage and you have a group of people doing that kind of thing, and you look back over the course of a period of time, it's really amazing how much you really improve things. Besides that, we know that mindset, looking for those little 2 second improvements, you will find and discover the larger improvement opportunities that are out there just because you're starting to hunt for those Easter eggs is what I call them, the real high payoff items. Okay, and then we should be doing everything we can to build collaborative teams. Okay, we just finished the World Series here in the U.S. Okay, if you have the best pitchers in the world, all $1 million pitchers, you're not going to the World Series. Okay, you've got to have the catchers, you've got to have the basemen, you've got to have the outfielders, and you have them all working together. So you have to have a balanced team, and they should be collaborative. We're all smarter together than anyone's individually. James Surowiecki taught us that in The Wisdom of Crowds. If you haven't read that book, it's worth a good read. Okay, but it shows the wisdom of crowds and the wisdom of teams that are set up properly will always beat any individual. I work with a lot of smart engineers. They are impressive. Okay, there are a lot of them nuclear engineers and they're chemical engineers, and they've invested heavily in their careers. They have advanced degrees. They're very smart. But what we don't do as well as we should is we don't play well together, is what I like to say. We don't work as collaborative teams. And it's amazing what will happen when teams really learn how to work together and collaborate well. One idea leads to another, and the collective ideas and collective wisdom is a whole lot better than any individual. And then finally, especially in engineering and the early parts of design, we need to capture and share knowledge as a most valuable asset. Now, these are actually captured, most of these are captured in the Agile Manifesto or the Lean Principles or Lean Enablers for Engineering, and you can find these are major published works out there that you can get your hands on. But notice, none of these really have that much to do with technology. They have all to do about the team. And if you're going to have your World Series winning team, these are the things that really need to be worked on as you're working on the operational technology. Okay. So what can you expect from this marriage made in heaven, is what I like to call it, for the Agile digital transformation? As a matter of fact, I will tell you, again, some leading experts out there say you will not do digital transformation in the OT space if you're not Agile, if you do not have the Agile mindset. So let's look at what's published by some of the leaders out there in the different areas that we can look at on expected improvement type work. Okay, so in the area of customer satisfaction, there's something that we use called the Net Promoter Score, and some of the leading publishers and consultants out there have showed routinely, starting in the mid-range of a Net Promoter Score, you can move up easily 15 or 20 points and so I've got the case studies I'll show you in just a minute and where this research comes from. We're looking for increases in efficiency and productivity. Always, any good engineer, any good operations manager is looking for that. We regularly see a 65 to 85% increase in efficiency and productivity with the OT digital transformation. We see improved decision makings. Okay, a lot of what needs to happen in our larger systems, and we've got to get people and experts together to make decisions, and they take a long time a lot of times because they're highly impactful. Okay, whether they're to our internal process or the ultimate delivery of product. Well, we have seen that we can improve decision making and reduce the time to get to a quality decision by 50% regularly. Okay, and then everybody wants to improve safety and compliance these days. Okay, we start all of our meetings with a safety consciousness kind of exercise. Okay, well, what's been proven is with the digital transformation, you can get a 40% reduction in incidents or compliance type issues. What about improving quality and consistency? That's what good engineering is all about, right? You can reduce defects right out the gate once this stuff is in place, and with your visual management and all these things, you improve your quality and consistency by reducing defects 35%. We always have an issue of franchising and scalability, I call it, and even flexibility when inevitable changes or emergent kind of situations come on the scene and we got to make changes. But you can improve your change rate or your adapting rate by 20%. And what about innovation and competitive advantage? Or we've seen the companies that do this easily gain a 10% market share because suddenly they can respond to the changes that we're all experiencing these days. All right, so where does all this data come from? I know this is an eye chart, but I'm just telling you, we didn't make this stuff up. I actually have more data than what it is, but we got Deloitte, McKinsey, all these high-powered consultants out there and leaders in industry, the Gartner, Forrester, speaking to the improvements in cycle time and forecasting, the ARC Advisor Group and Accenture and Deloitte and Price Waterhouse Cooper say the incident rate goes down by 40%. I didn't tell you about some of these. I just gave you the main ones, but the compliance scores have gone up 95%. Operational costs down 25%, even while energy use has been reduced by 50%. Defect rate reduced by 35%. I showed you that. The yield rate, though, is up 98%. That's really what you're after, right? And so because of your not having your outages in your first pass yield, that's what we call that, that you can improve that by 98%. That is huge. Time to market reduced by 20%, adaption rate up 30%. Then we've got market share up 10%. Patent filings increased by 50% for these companies, reported by GE Digital and Harvard Business Review. And then the net promoter score that I told you about was increasing from, let's just say where it averaged about the mid-range in the 50s, easily up to 70 and plus. And the net promoter score, really does speak to overall market appreciation and presence. And this is why the retention rate, which is really as much of what you're after in the market, is up by 15%. And that's Salesforce and Bain & Company did that. So we have a lot of deeper dive that you can go in for this kind of thing. And we have the references. I think Brad is going to make the slides available to you all, and you can look this stuff up for yourself. But we're just making the case. We're hitting the high points. Let's keep going. Okay, so let's talk about more of the AgileDX side on when you do this right, what does it look like on the front line, in the field, where the people work, okay? So what I'm going to show you next are actually photographs and slides taken from the front line and probably the leading companies in the world right now in doing this, and I'm going to end with showing you what the results that they have gotten, okay? So first of all, the visual management means that I am showing what is happening within our processes in real time. Now notice, I could have taken you to a control room and showed you that, but this is out on the production floor in the normal passageways on this particular plant. If you go to the various points in the processes, you have this also indicated. And the rule of these kinds of indicators is that if the people that are working on these things can't make a difference, then we don't display that, okay? That's not a real score that I can do anything about. When I'm in the ball game, in that World Series game, there's no use telling me about the score in the overall industry. You need to tell me about the score in this game, and being able to see that and seeing some of the statistical details as our scorekeepers are giving that back to us, we'll make a game change modification. So that's really what this is about. So real-time visual management. There's a way that we get our folks to think, and then we got real-time scorekeeping that we can do something about. If we're not scoring like we think we need to, we got something that we can aim our activities to resolve. what we're looking at here is, and I'll focus on a couple of these things, that this starts getting to specific real-time feedback against the goals. So in these screens that we captured, we'll see that the goals were to continue to reduce the cost of the existing products. This particular company from 2018 to 22 reduced their cost by 30% with no reduction in their delivery or cost overhead. Now, mind you, we're talking about major times of increasing cost, and they're reducing their cost. Now, that is directly a result of the people working on these things and the engineering going into it and the agile teams that are pushing that forward. Look at this. This is where in this particular company, you'll start detecting this shortly, is an EV type company. They have a 30% quicker charge time. Well, that's in terms of customer value. But notice over here, they have a 30% reduction in cost. That's huge. That I'm increasing the customer value even as I'm giving better value to the customer and to the other stakeholders. Okay. And so this is the Agile team combined with the digital transformation, which is really bigger numbers overall. What this is showing than what I showed you that the industry experts said you could do a digital transformation. Notice this slide here is a little bit hard to see on what it takes to ramp up what they call a gigafactory. The ramp up lines are shown in production and delivery by the blue lines here. Okay, these are two different locations. Notice that the labor and resource rates were going down even as production was going up. Delivery and production was going up. Same thing here, that the resources are going down that are applied to this, almost to flatlining at bottoming out. That and I'm telling you what's happening. Okay, think of again what our digital transformation is doing for us. We're automating more and more as we understand better and better how to make that happen. That's what these charts are showing. And so what it takes to ramp up a factory. This was from their startup, lots of low production, but lots of people and resource into this, and then it starts taking a nosedive because they got things starting to move. And here it is over the course of this particular 1 year, a little bit more, a year and a half. Okay, this is what happened to these two environments, and what they're focusing on are simultaneously all of these things. These are where the ideas come from and their improvement opportunities and their growth. They're aiming at how can we improve growth? How can we improve productivity? How can we get overhead efficient? So it's not either of these, and this is a big concept that's true in Agile. You do not have an Agile or a lean solution if it's a zero-sum game. Okay, and let me just make sure we're all on the same page on zero-sum game. That means we win over here and we lose over there. Okay, a lean solution, according to the rules, an Agile solution is that if everyone isn't winning or all of the contradictions aren't improving, then you do not have a lean solution yet. Now, you can't get there all the time in the first step. That's why it's a mindset of continuous process improvement. I'll show you how that plays out in detail on the next set of slides here. Okay, you do it with modularity, okay, in increments and concurrency, okay, and you cannot do that if you do not have an Agile team. The thinking. Notice I keep using the word thinking in all of these slides that I'm showing you on the front line. They think in terms of modularity. What can we do to break this stuff down so that we can work on things simultaneously? That's called concurrent engineering, right? Well, you can't do that, though, if you don't do things in small increments, if you don't break things down. And we as engineers like to so many times overcomplicate things and over-engineer things. But if you break them down, you can make a lot of little improvements. So here's what happens in this cooling system, basically, and heating system for this particular truck right here. Showing the red over here shows you what's being applied to. This thing started out with 100+ subsystems. This is what it started out as, okay? And so they started taking it on and say, okay, what can we do to improve this? What can we do to, minimize components? But no allowance for changing the outputs and so forth. And their version 2 got a whole lot simpler, okay, as they started working. By the way, they were producing these while they were working. And then they start producing these in parallel and doing experiments and making it work. Agile is always about producing prototypes and experiments. When the experiment shows that they're producing something better than the original right now, then they move right on into putting that into the line in Agile space. Look what happens in version 3. Good gracious. They basically have collapsed this into highly modularized compact unit, okay? That now, look at all the space gain back in the major super system that you're building, quote, the truck, okay? And then here's what you end up doing. It took up all this space, spread all over this. This was all the pieces, and now it's down to this. And this occurred, let's see, I was looking for the date on it. This occurred fairly rapidly. I'll put it to you that way. I'm sorry I don't have the timeline. All right, but I'm going to prove to you the timeline issues in just a second here. Here we go. Okay, so this particular company that we're pointing to is a rocket company. Okay, they are flagging right here that they to get to where they wanted to go, to get this this rocket into the air from the previous version, they needed to make 1,000 engineering changes. Now, mind you, everything about these changes has to be certified and approved by oversight committees that belong to the government and the FAA and all these kind of things, because they're not going to let you throw anything into the air that hasn't been approved by committees of experts, okay? But notice this 1,000 changes were processed both physically on the article and the approvals and the bureaucracy that it had to go through in 69 days. They're doing something different, okay, in this particular operation. Think interface, modules, and increments. So they have taken this as a religious experience, is what I like to say. I don't think there's any company that I've ever worked in engineering, and I work in, as you heard, the nuclear business right now. You don't do, to make one single little change to try to even get it done in 69 days is ridiculous. If you go to the main manufacturers in automotive or other industrial processes out there, they cannot make a change, too many changes within a quarter or a half-year cycle. They just don't do it. They freeze it, okay? And what they do is they get something approved, and then they build everything to that standard and prove us to that standard. This company does not do that. They actually make the changes. And again, I can give you a whole lot of detail on how it's done. It's basically done like we do in software engineering, is that we build APIs, we call it application programming interfaces. And we can, when we break things into microservices to do that, I can, as long as my input from that API to that functional service equals the output that I'm expecting, I can stick anything in between there and make module design changes all I want. But I can also build those in parallel. And when my new design is better than my other design, I can immediately switch it over. That is the way they make these changes. So they'll have that all written up and go into the certifiers and regulators, just one after another. They're ready to make them. All right. So let's go to what what this looks like. And by the way, the company is SpaceX, if you hadn't figured it out by now. So if you wonder why SpaceX has taken over the rocket trucking business to put stuff into space, this is why. And you'll see it graphically in just a few minutes. They have a 1,000-year goal. That doesn't do me in day-to-day work, but they also are identifying bottlenecks in their process immediately now. They then have these child KPIs that identify these bottlenecks that they need to and their goals that they're trying to do. And then they take those child KPIs and break them down into incremental daily improvements. In other words, I'm only going to work to take a gram of weight off this thing. Weight's everything in the space business, right? So they're always looking for ways to cut weight, still maintain the strength, still maintain the integrity, but we're cutting it. So, and then of course they see everything as an experiment. Even as they're working on the real thing, they'll be working on an improvement right next to it as they're going down, as they're doing their production environment. Okay. And so the goal is to keep reducing the cost of putting something in orbit. All right. Let's take a look at that in closer detail later. All right. So this is how it relates back to another particular factory. If you hadn't figured out what this one is Tesla. Okay. So look at what happens here. Notice this chart here is cost. They're trying to drive costs down. This chart here is drive weight down. This chart here is to drive the power requirements down. So those are meaningful when you're in the electrical vehicle business. Is that right? I need to get my cost down, I need to get my weight down, I need to get my power down. Let's see what happens when they're taking this on. So here it is on a timeline. And what they've done in this period of time is they've reduced their cost by 24%. Is that significant in the delivery of a final product? Yes, it is. Okay. They don't even make that kind of margin on cars. Well, guess who does make that kind of margin on cars? They were already good, having a decent margin. They just improve their margin if they don't change the price of the car by 24%. They may make a strategic decision to change the price of the car, which increases their competitiveness in the market. That's not what they're aiming for most of the time. They're aiming for better margins for all the stakeholders. That's why Tesla, by the way, and I hadn't checked this lately, I think they have more millionaires working for them than anybody else in any other company. And the reason is because they share that profit with their employees. You don't find anybody not wanting to work that's working for Tesla or SpaceX or any of the other Elon Musk companies that doesn't want to work there. They will leave, okay? Because they don't pay that well as a base salary, but their profit sharing and their stock options are huge. And they've got people working on the front lines that are millionaires. They don't have to really work, but they like working there. They reduced the weight by 12% in the same period, and they reduced the power consumption. Is reducing power consumption a big deal in the EV world? Yes, it is. From 27 watts to 18 watts is a big deal. Okay. So they're thinking along those lines all the time. Now, how do they get these collaborative teams to work together? And I'm going to drive to a conclusion pretty quickly here because we're going to be running out of time. If you hadn't figured this out, I'm kind of passionate about this stuff. I love sharing this. And by the way, I'm really impressed because I saw on the attendees today, there was a dog up there in the people, and I've never had a dog. I do such a good presentation that even dogs like to come to my presentations, I figured out. So there it is. All right. You may not have seen that, but we do have a dog in attendance here. All right. So think collaborative team-based work. They have a very interesting model. What you're going to look here is the evolution of a particular system, of a heat pump line. Okay. And this is the progression right here. Started here, and here's where we go. All right. So they started with just basically hands-on working on this thing so that the people working on it know what it is, know where it fits and all that. And they literally, it almost looks to me like an arts and crafts project. And they do this over and over again. Okay. Then, of course, as soon as they can, they start getting it into an automated or semi-automated mode. Okay, and they're learning there. So not only are they learning how to build the product, now they're learning how to process the product better and to automate it. Then you go into the area where they start doing computer-based modeling and simulation to figure out how to do it even better. Okay. And then, of course, you end up that it's totally automated before they get done, because their modeling helps influence the design, and their modeling also helps influence the process for doing it. So they really have taken a lot of the software things that we learned earlier in the Agile and Lean space, and they are applying it to hardware. That explains a lot. Okay, how do they do that? How do they form their teams? This is probably the most unique thing that you'll ever hear if you don't know anything about how they do their work there. On the bottom down here, we've got the roles that are on every team that they're working. On the top is what they call it. They call it Mob AI. So it's group-based work, team-based work, and it's full of artificial intelligence. So what does that look like? Let's go down to the team and deconstruct it. On every team that's working in this agile environment with the digital transformation, because they're using the digital transformation tools that we described up there, they have a driver doing the primary work. They have a navigator who's telling the driver what he thinks they ought to be doing, and they're talking back and forth to just air it out, make it what people are thinking come to the surface. And then they have between 2 and 5 researchers behind them looking up the answers to problems. Now, when that driver sits down, he's going to be intensely working to listen and try to understand what these people are saying and do what he knows how to do too, to deliver to a specific goal that they've done. Now, they do this with computer work. They do it with physical hands-on work the same way. Okay, it's just the application is a little different. So the driver works until he accomplishes what the task was, what the goal was, generally broken down in between 7 and 15-minute type increments. When he has accomplished the goal, he rotates around into a researcher mode, and the navigator goes to be the driver. And then one of those researchers is now going to be the navigator. And they do that, and they work typically 10 to 12-hour shifts. The whole team is doing that all day. Now, this solves a myriad of problems. That if you want to train up a team fast, that's the way to do it, on what the real work is being done and all that kind of thing. Okay? But not only that, they're delivering incredible results, and I'm going to show you what those results are in just a minute. Okay. Now, before I do that, before I show you the results, I want to talk about this being applied in the most highly regulated industries across the country, the highest risk companies across the country, and the highest bureaucratic companies across the country. Because most people will say, and we say, well, Agile won't work here. They'll say because we're too bureaucratic, or they'll say, no, it's because we're high risk and we can't do this kind of thing. Say, no, because we're, anyway, so let's go. And SpaceX is one company. Starlink Satellite Communications is another company. The Tesla electric vehicles is another company. Neuralink is actually medical devices, implanted medical devices, particularly related to neurological things. So spinal cord industries or nerve destruction that can be worked on. And then the Boring Company. A lot of people don't know about Elon Musk's Boring Company. That was the one that was going to build the tubes. Well, they still are out there boring holes better than any other company in the world, by the way. Okay. And there's 2 other companies now that are the Musk companies. That's X and X Artificial Intelligence. I don't have any information on those, but I suspect they're run the same way. And here's why. Here's the first solution. That we are working in very highly regulated, high-risk environments, including aviation, highway safety, medical practice, space, and tunneling. You don't do any of that work without a serious set of regulators looking at everything you do. Safety being of the premier importance. That's why SpaceX will blow their rockets up rather than have them go off course and things. And it's interesting to hear what they have to say when they blow one up about how much they learned on that particular exercise. Okay. Starlink, I think they've, been famous lately because they've helped in the Ukrainian war, and of course now in the disaster relief. They were the only people who get communication into these blighted areas. Okay, and the Tesla electric vehicles, I got some data for you on that in a minute. And Neuralink just had some major breakthroughs on people that were total quadriplegics, that can now do things and play games and do things that they couldn't do before because of the neural implants. And Boring Company, they're basically underground, so you don't hear about them. But they're a very successful company. All these companies are industry leaders. Okay, so they have that unparalleled incremental set of improvements, 1,000 changes in 90 days, and everything is 100% certified by regulators. Highly bureaucratic. Every Tesla electric vehicle is not certified to a standard that was approved. It is 100% certified itself by the regulators. They have a process that can happen. Most of it is through digital AI means, but it is actually posted to be reviewed, and somebody really does have to check off on it. And so when you take your vehicle for service, they pull up your specific vehicle specifications. Not only that, but the specific drawings, because these 1,000 changes that they'll make in 90 days, you may have a different regulator or a different relay in your vehicle that's not in the other ones, that the one that was made just before yours is not made like yours, because it was a better solution that they had been working on, and that what went into your vehicle. So they make those changes not in normal, delivery cycles, but they make them when they decide that it's ready to be implemented. Nobody does that. That's why the typical auto manufacturers, it takes them 4 years to put out a new model from a clean sheet. And they don't make any changes to it, except, once a year when they make the model changes, they'll make some changes, not many. Okay. And then, of course, let's just tell you what the return on investment. I could tell you on all of these, but I don't have the time. The one I'm going to tell you about is Tesla. Tesla is the highest company in market capital in the industry. It takes the next 8 auto manufacturing companies to equal what Tesla is worth. Okay. Tesla does not sell the most vehicles, but Tesla has the most margin in their vehicles of any other automotive manufacturer in the world. And it takes GM, it takes Ford, it takes Chrysler, it takes a handful of others, 8 of them, the next 8 in line, to equal what Tesla's market capitalization is worth. And I could tell you about that and all the others. So that's basically what it is. And I'm going to show you where it's really dramatic. The cost of space flight is historically been, look at here, what you're seeing on the screen is it's been from 25,000 to 50,000 to put 1 kilogram up into orbit since all the way up to 2005, from the early 60s up to 2005. Okay, notice it's fairly flat. This chart shows what the cost is. The reality, it's more than this. That's because most of these guys that were doing it before it was commercialized, their numbers aren't real. Okay, they were government numbers. They were or either government-sponsored organizations, and so there's a lot of hidden costs. Well, in the commercial world, there are no hidden costs. Okay, and so in about 2005, where SpaceX went into business, notice what happened here. They started right up there with the rest of them on what it was costing, so that, if they did a good job, they'd still get work. Okay, but look what's happened. over the course of a decade and a half, they have basically brought the cost to less than $200 per kilogram. Okay. It's actually going to be below that by the end of 2025 when they actually have their latest heavy rocket that's going to be going into space. Okay. This is why you look at the stock market, and someone who was really not in any of these industries 2 decades ago has taken them over. It's not because he's a rocket surgeon. It's not because he was an automotive engineer. It's not because he was a medical person or a boring company. It's because of the processes that are being used in these industries now. So there's your proof case. With that, I'm basically done. I really appreciate you all giving me the time to do this. I do have a passion for it. I have been involved in a lot of different sides of this thing that we could talk about, but we're having a good time. I especially have a good time when I get to share the good stories, because at the end of the day, I'll tell you what, those teams that are engaged in these things, they like it a lot. A lot of them will tell you, I don't want to change. This is, I go to these other places and the bureaucracy weighs me down, and the churn that I have to go through. I go to these places and I really do something. I launch rockets. I build vehicles that are noteworthy. I am taking people that are not doing well, and I can help bring back their ability to live their life, that kind of stuff. So I hope that was inspirational. I hope that was useful. And I did have to skim across the top, and I apologize, but I'm almost getting into overtime here. So with that, I'm gonna give it back to Brad, and whoever, and we'll take questions if you have any.
Does anybody have any questions?
Hey, Tom, this is
Yes,
Bryce
this
Johnson.
is Howard Nichols.
Oh, go ahead, Howard.
Well, this would be my question. Given, not to be, make a too political a statement, but given Elon Musk's relationship and the statements from President Trump, do you see him installing these same cost efficiencies into his new position in the Department of Government Efficiency? And do you think they'll be successful given government bureaucracies?
Okay, I'm going to give you a caveat here first, and Brad will vouch for this. I was supposed to give this about a year ago, and so I didn't expect, and I knew that this was a good chance this would come up. This is not meant to be political at all, and I apologize for you all if you take it that way. I have my own opinions about different things, but so my answer is going to be not political. It's going to be the truth as I know it and see it. Why would you not apply this? I have worked regularly in government contractors that we have a double layer of bureaucracy, and we have repeatedly done pilots to prove that it will work. Agile methods will work. The digital transformation, nobody argues about that, okay? But that's a major investment in technology and education and training and change. The agile methods actually embrace change. Okay, so back to the short answer, I would absolutely expect, as a matter of fact, some of the highest payoffs, if you go to Washington State, and I mentioned to you Paul Akers in 2 Second Lean, he is actually working with the Washington State government, that they've been implementing agile methods for a good while, and they have some pretty good use cases that they can show. So the answer was yes, I would expect. Now, I hope it becomes less political, but I'm not convinced that will be the case. But the reality is they've said they're going to be transparent. And if they are, then you can see obviously that something ought to happen or not. Did that answer the question? That's my opinion. How's that?
Thank you, Tom. Bryce.
Hey, Tom, this is Bryce Johnson. I don't know if
Hey,
you remember
Bryce.
me. We worked together at the Trillium facility
Yep,
for
yeah.
a few years. One thing that I noticed during your presentation, I mean, you led with talking about project management and how Agile can play a role. One thing that I'm kind of curious about is that a big part of the Agile manifesto is talking about welcoming changes even at a late position in the project. So with that being a core competency of the Agile framework, can you speak to the Agile method for project management when that has historically been under the waterfall method of accomplishing one grouping of tasks and then proceeding to the next?
Okay, that's a, I'm going to tell you that it can work, okay? Because you can bound things within, we work in increments, okay? And you can bound things within modules so that you can, as long as you define the right inputs and the outputs, as organizations' confidence grows, it shouldn't matter as much what happens inside. You still got to comply with all the rules and all the safety requirements, all that kind of thing. But we've actually been criticized, Bryce, and I've been a part of this, that we weren't thinking innovative enough in some of our long-term thinking. Well, Agile welcomes that, and of course, when you do the risk assessments, you'll identify what's sure and what's at risk. Okay, and some of these changes, when things are at risk, you actually break them down into smaller pieces so that your risk is reduced in that way. So this is a bit of a complex question, but it will work here. Okay, and I get what you're saying. The long term, we've done pilots and we can make progress. But I'll tell you, it did take time as you looked at the Musk models of improvement and the cost reduction. That's the one thing. It was the cost of putting a kilogram into space. But it was a steady trend line down. It didn't happen instantly. They did it over a good period of time. They can move faster now because the confidence of the regulators, and they're not cutting corners. They're put safety first and those kinds of things. I hope that gets on the way to answer the question. You and I can have further conversations on this because I welcome them. But and that puts me back on the job because I know the work that you're involved in too. So did that help? I couldn't dig deep because we don't have the time. But
I think you were definitely moving in the direction that answering the question the way I kind of expected, but thank you for spending a moment to talk to that. I have another question. If no one else does, I'm more than happy to wait.
Go for it.
So you listed out some of the Elon Musk companies, right? And you talked to them rather extensively about Agile, and I have no doubt that they used Agile, but all of the industries that were listed are engineering, have engineering as the core competency, and they're very complex, with very complex products, you might would say. I mean, not so distinctly different from how complex the nuclear security enterprise is. How much do you attribute the emphasis on engineering tools such as models-based systems engineering and enterprise architecture? How much do you attribute that to the success of the companies, or do you feel that Agile is still the primary function? I know that they can coexist, but I see those tools and the emphasis on them playing a larger factor
okay,
than what you've spoken to up to this
yeah.
point.
Okay, let me Isn't this funny? All right. So whenever I share what I get from the engineering companies on agile approaches, because you have to use simple models to start playing, showing the concept. So we use things like a sub sandwich shop, or we leave, how they work, and it's all visual. Da 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 da. Brad can tell you about this. Brad did a lot of this work in the days when we were training this. They say, yeah, but we're not McDonald's, and we're not Subway, and we're not this. So we go from the simple side that it works, and then our engineering buddies say, well, it won't work for our complex environments and our highly regulated, highly bureaucratic. Well, I just showed you several that it's working in. Those guys do not move, and even the highway safety quote with self-driving cars, they cannot put them on the street without a very, very high rigorous kind of approach. Okay. All right. So what I'm saying is that you have to have different ways to apply it, but it has payoff and proven long history of that now. It used to be when we were early into this thing, it was mostly in software engineering. People say, yeah, but it won't work here for this reason. I've heard that over time. I got, and Brad can vouch for this. I've had arguments with chief engineers because they say, well, you can't get improvements out of my process. And I said, well, I hadn't seen one yet that I couldn't pull 50% out of. Okay. Now that's pretty cocky. And I apologize for being that way sometimes, but I'm telling you, it's usually a whole lot more than that. But I've had chief engineers say, you won't get out of mine. I got a great team. See, it's not that the people aren't good. It's that our processes stink. That's what we're really after. And when you get into lean and agile, that's what you start looking for. We're not blaming the people most of the time, 99.99% of the time. What we're blaming is the process has opportunities for improvement. And if you look around you, it's not your guys on your team, Bryce, that are not getting stuff done because they don't want to get something done. It's usually because of the bureaucracy that gets into the way or the waste that we have in our processes. Now, I don't know if I answered that question for you, but I tried to kind of reframe it if I didn't, because this is what we get. Well, yeah, I get it. It works over there, but it won't work here. I can tell you that it's been proven to work. And there are a bunch of movers out there because they've seen what's happened, and they also, oh no, they never work. Well, then they go over and look at the Musk company. The Musk companies, the only reason I point to them is because they're transparent. You can get the information. If I go to Toyota, now they're a little bit transparent too. If I go to Bridgestone and some of these others, they're not as open. It's harder to get the information. Now, if I was an academic and consultant, I could get into some of those companies, but we can't. So
Since we last talked, I've actually changed companies. I work at SRNL now. But going back, one thing I think is very interesting challenge that a lot of these companies that are listed, I don't think they necessarily have to face in the same way, that within the weapons complex itself, we have a lot of different actors who are owned by various contractors. So the streamline approach, seamless quote digital thread, if you want to use that term, I think is less of a fight for a lot of those companies, where you can actually apply the agile approaches and have a stream of information where you can make on-demand changes like what you were referencing. But I think one thing that we face, I know there's a number of people here that are in the weapons complex, some that aren't, is that we're, like I said, that the labs that are out west that the gentleman earlier, Larry, was speaking to, that were all owned by or ran by different contractors with different sets of tools, different sets of core competencies. which is kind of broken up the cohesiveness of what you're seeing out of companies like Tesla, out of SpaceX, Honda. EasyGo is another example. I don't know if I'm necessarily asking a question out of this, more of just a comment in addition to what you've already presented on. But it's all very, very interesting question to answer that plays into this overarching term,
Okay.
digital
So
transformation.
let me add to that to cap that off. So what you're talking about is not a technical problem. It is not a process problem. It is a cultural problem that you're speaking to. And I wholeheartedly concur. You have to have leadership that wants to move through this thing, or there's got to be some, it's either leadership or forced accountability in some fashion, or you got to have a cause so strong that people will rally around it. That's classic change management. So with that, I think you made the case very well that most of the time, the reason we're not doing this is not because we don't have enough proof cases to show it will work. What the problem is our own cultural biases or financial biases or whatever other, you know, other priorities that we have.
Do we have any other questions? Well, if not, Tom, I would like to thank you very wholeheartedly for you were supposed to give this talk a long time ago. And then most recently last month, we had a hurricane come through South Carolina and we didn't have power at this facility. So we had to reschedule, and we are so grateful that you were flexible and came back. So will you come back in the future sometime?
Yeah, I did one for you guys about 4 or 5 years ago. So that's about all you can stand of me about every 4 or 5 years. So we actually did a early pilot presentation on that we were doing at the time to prove that it would work in a bureaucratic governmental environment. And by the way, Roger Duke, who presented a few months back, that I moved out of the way so he could produce because we wanted to get him. He when he was out at the site, he worked on those projects with us.
Well, I remember those projects. I remember that pilot you're speaking of.
Yep.
We worked together at the time. Well, thank you so much for your presentation, Tom. We are grateful. If I could take a moment and just wrap things up for the audience. We have 3 upcoming section meetings. You can see January, February, and March shown on the slide. John Holman's going to be giving a talk on estimating from the owner's perspective. Casey Prouty is going to be doing a soft skills, emotional intelligence talk, stronger, more cohesive teams. And Lisa Coleman is going to be speaking on risk, impacts, and responses. Oh my. So we're looking forward to those upcoming talks. We would hope you would consider coming back. All of you, we're going to not beat up your inbox, but we are going to send you a periodic email just letting you know what's coming. If you decide, hey, it's too much, just unsubscribe. But we would love to have you come join us. And I think that's all we have for this evening. Thank you all so much for your time. Thank you for your questions and your participation.